Good morning to you all. I welcome you to this virtual lesson. I sincerely hope you are having a nice quarantine. My name is Daniel and I'm going to talk today about a very particular and interesting subject, very relevant as well, which is cybersecurity and cyber terrorism. We will be analyzing some of the most important cyber attacks known in history. We are going to try to understand how they work, how they were executed and deployed. To begin with, I would like to discuss a very important concept, which is cyberspace. Everything we are going to discuss today happens on the cyberspace. So, when we talk about cyberspace, we always be referring to the digital systems that runs a lot of different processes and tasks all around the world in modern society. Although this concept of cyberspace could seem so far away from our domain or our interest, it is crucial to understand that we are greatly affected by it. We make part of it. We have contact with all of these digital systems in every single day of our lives. These systems, for example, are present in our massive transportation, our communications. They run our financial systems, some of the healthcare equipments, for example, or even the air traffic control. A lot of these different kind of processes are interconnected in what it's called the digital networks, right? And these digital networks are the ones used by hackers to spread their cyber attacks. Okay, so we are going to take a moment right here to explain very briefly what a hacker is. So a hacker, it's a person which has a computing and communication skill base and knowledge. And these persons will always be searching for certain flaws in any given system. And once they found these flaws, they are going to take advantage of them in very different ways. So in cyber attacks in history, we may find some common intentions or purposes. One of them could be, for example, the stealing or altering or even destroying of delicate, sensible, or confidential information. You could take a second just to think about the great amount of information that it's out there, that it's protected, could be by the state or by private institutions, right? Very important information that it's completely secret, and it's very important for them that this information will not be spread. So these hackers will attack certain databases to steal this information, and then they could do whatever they want with it. So for example, it's very common that a hacker will attack a database of a bank, for example, and will steal your password and your account information. So tomorrow he can make a transfer of money from this account to another one, and this could be rarely traceable, and it could be a riskless steal, right? And that's just one way to make a profit out of it, right? You can sell this data. We are going to look at data management a little further when we discuss Cambridge Analytica case just in a few moments, right? But mainly these leaks of information constitute one, if not the angular stone of these first cyber attacks. Okay, Secondly, we can find, for example, these attacks that are focused on damaging hardware. So we could make really fast, really quickly differentiation about hardware and software. Here I have a laptop. So all this plastic or metal or whatever materials this is made of, it's the hardware, right? But inside of it, there's a software running, right? The operating system or any given application or program that I install on it, right? This is software. So the hardware damage is caused because via software we are going to introduce some different orders to the system that will occasionate this profound hardware damage. So this is one of the most common viruses or cyber attacks that we know, because we may own our own laptop, and we could be attacked by different viruses if we enter maybe some websites that are not really advisable. Okay? So this happens to a lot of people, not necessarily people involved in this kind of subjects, right? Or fields. Right. So we have other kind of attacks. We can find as well a lot of activists or idealists who just want to spread a message. So they will hack a website with a lot of traffic, and then they will post whatever they want to communicate to thousands or millions of people who may enter that website in any given day, right? So yeah, and finally I would like to point that some of these cyber attacks in history have been made not by individual hackers, but by entire nations who have deployed the most powerful cyber attacks in history. We will be discussing first of all Stuxnet in a moment, and then we are going to be discussing also NotPetya virus, and these are very powerful viruses that were released by entire nations in a co-working situation. Okay, so these are fairly most dangerous and powerful. Okay, so guys, it's very important to understand right from the scratch the reach that these cyber attacks could have, right? Because as I told you before, these digital systems are present in, for example, our communications or transportation. These systems were built decades ago without the thought of cybersecurity. They never have expected to be attacked in a near future, okay? But if we see today's most recent inventions, we will find that every time there will be more products that are connected to the internet, right? We can buy a smart TV or whatever, like a smartphone, right? This smart term, it's applied to whatever object it's connected to the internet right now. But this is getting a little crazy. Like you can buy today a smart fridge, for example, then download an application and you can just watch your food on these applications and monitor the temperature and stuff like that. And of course, if you buy a fridge that is smart, of course it will not be protected against any other against a cyber attack. Like it's maybe not that likely to happen, right? Like someone attacks your fridge. But what if I told you that, for example, someone wants to generate a social crisis, a hunger around a certain region, and they could attack all the smart fridges on that region and just modify the temperature, and therefore all the food will be wasted, right? It is as simple as that, right? In a future in which maybe all of us have a smart fridge, it's just an example, but let me go further with these examples. Today, for example, the car industry is getting very high, very long steps in this direction. So, for example, you can have a big car, a truck or whatever, that runs a digital program that tells you all the functioning characteristics that you need to know, right? You can monitor the oil levels or your gas levels as you can do it today, or whatever you want to know about your car. But for example, what if some hacker would like you to go faster? You are driving your car and in just 1 second the car starts to run a lot faster and it causes an accident, and you cannot control it because it has been controlled by a hacker 1,000 miles away, right? So this is another very maybe crazy example, but it is just up to your imagination. That's my point. It has no limits. Let me just put an example that will maybe more likely to happen in modern warfare. You know, there is drones right there at service of any advanced military army, right? And these non-tripulated aircrafts are programmed, for example, to toss a bomb in certain region, right? What if a hacker just reprogram this aircraft to toss the bomb in other target? You may be receiving your own bombs from your own aircrafts because they are being hacked. Okay, so as we advance in production and inventions, we kind of go backwards in this sense because we are every time more exposed to be attacked by these hackers, right? To receive a cyber attack. So it is very important to underline that nations, mainly nations, but also a lot of different enterprises on the private sector, are increasingly being interested on developing a cybersecurity for their information, for their hardware, or for whatever process they run on their facilities. Okay? Well, I hope these past examples gave you an idea of what can be achieved by deploying a cyber attack. You may have noticed that the hacker capabilities allow him not only to shut down or to crush an entire system, but maybe just to slightly modify the way they function so they can have a different outcome that the one was originally expected from this particular system. This is very dangerous, very dangerous indeed, because it gives the ability to cyber attacks of being undetectable. Okay, what do I mean by that? Let's just imagine a facility in which whatever process goes on. Okay, so let's imagine that this facility is being under a cyber attack. So the process has been slightly modified so that the outcome that is expected will never occur, right? Engineers will be trying to fix that problem by any means they can, using all of their knowledge, right? But it could take months or years to detect that they have been under attack, or maybe they will never know it. Okay, today this possibility of being under a cyber attack has to be taken into consideration, right? But it wasn't like that back in 2010 when Stuxnet was first detected. Stuxnet was a very revolutionary cyber attack created in a co-working operation between the Israeli and the USA government. And it was conceived to prevent Iran to develop a successful nuclear program. The responsibility of these two nations behind it has never been proved. Not maybe until this NSA agent took responsibility for all the United States and spoke about how the Israeli government was involved. Other than that, this cyber attack could have been untraceable. On the other hand, these two nations were the most likely to be interested in making something like this happen. The context, historically speaking, that led these two nations to take this road of the cyber attack, I am positive that your Professor Sebastian could illustrate it with a lot more accuracy and detail. So I am going to be focusing in how this virus worked, how it was deployed, and how it was detected, and trying to analyze the impact that it may have made. So back in 2010, alarms all over the world started to ring because of a new virus was circulating, a new unknown virus. It was first detected in Belarus, and then it got the attention of the private enterprises who are always fighting malware or viruses. Okay, we can speak about, for example, Norton or Avast or Kaspersky, as is the one who appears on the documentary. These enterprises, alongside with very few entities all around the globe, are 24/7 looking for different malwares. And here is something that we have to underline, it's very important, and it is that daily thousands of cyber attacks are deployed. So these entities and these enterprises have the incredible task to choose between them the ones they think have the more potential, the biggest potential for making damage. Thousands of computers in a lot of different countries, almost all over the world, start getting infected with this virus. But the way the virus worked was very mysterious, because the hardware didn't suffer a damage as the one we were used to see with another viruses before. Okay, so this virus will only produce some occasional shutdowns of the system, and that's it. So it was very rare. Okay, and then again it was everywhere, so it got a lot of attention. It is very important to point out that these private and public organizations who try to track these malwares down will first just identify it, but they have to work really hard to understand what is the purpose behind it. Like, what will occur if this virus enters an operation? What is the main goal behind it? Okay, so even if these people have a lot of experience, right, working day by day with these kind of things, they took more than a month to begin understanding what it was that it was trying to do. Okay, so that gives you an idea of how complex this code was. In addition to that, this code had at least 4 different pieces of code that were never seen before, and this is very, very rare. This is called a 0 days code, and what it means is that it has been 0 days on circulation, so no one has seen it before and no one has the counterpart to to avoid this code of being damaging. Okay, this is very, very important, and it was a very crucial clue in all of this tracking process. Why is that? The thing is that these codes, these 0 days code, are worth thousands of dollars, and they are sold on the black market, the deep web mainly, by hackers who have logically a higher level. Okay, not every hacker is capable of creating a code from scratch. Okay, so these people had in their hands a new piece of code that was at least 20 times bigger than anything that they had seen to that date. In addition, it contained these 4 fragments of 0 days code. I say fragments because you can imagine a big piece of code, a lot of different digits in which these 0 days could represent only a few lines of it. Okay, and here is important to understand that in any given code-based activity, for example, when you want to build a website or to code a video game, you as a programmer will be always recycling pieces of code to make your life easier, or just to spend less time on this project, on this development. Okay, so hackers do that as well. Okay, so that's why I told you that only really experienced hackers could pull off a 0 days code, because the rest of them will try to make damage using code that it's already invented. In a normal scenario, these guys would have identified the purpose of the code in a matter of minutes. Okay, but this was something special. Something big was going on. Then they will detect that the country that had the higher number of infected computers was Iran, which was very curious and drew a lot of their attention. So they began looking at the news and found very, very interesting things. They will here start to understand the dimension of this attack, because they will find on the news a series of murders of scientists who used to work on the Natanz nuclear facility. So they will begin to wonder, is it possible that somehow these murders are related to this cyber attack? It would make sense, right? Because you have a massive attack as this one, very complex, as anyone's seen before, okay? With a great budget behind it, because they've spent more than $1 million buying these 0 days codes that it contains, right? And also they knew by now that it wasn't profitable. I mean, it is very usual that the people who spend that kind of money on 0 days code will utilize it to earn profit somehow, illegally, logically. Okay? So it would make sense, and this was one of the first clues they had to point this facility as the possible target of this attack. Then they will find another very important clue, and it was that in the code they detect that this attack was targeting a very specific type of hardware, which is called a PLC. That stands for Program Logic Controller. And this is a piece of hardware that runs a digital program which is very versatile. Okay? This piece of hardware can be attached to a lot of different machines to fulfill a lot of different processes. In further investigations, they will discover that this particular model of PLC that were targeted by Stuxnet was produced in some factories in Iran, and it was used on this nuclear facility. But here is where this code really stands out from whichever code they had seen before. Let me tell you why. In programming, there is something that we call the conditional functions. So these conditional functions will only be executed if a list of conditions are met, okay? If all those conditions are fulfilled, then these functions will be executed, okay? Only if that happens, okay? So this virus was very picky indeed, because it will identify the system in which it was running, and only if it detected a series of parameters, between them the PLC that was targeted, only then it will act, it will enter in operation. And this is why, even if there was thousands of infected computers in the world, only the ones they were targeting will be really affected by the virus. But then they found the final proof. They were able to confirm that Natanz nuclear facility was targeted by Stuxnet. And how did they do that? They detected inside the Stuxnet code a piece of code that was an array. An array in programming lets you group any number of objects of similar kind, okay? And when they make a contrast with the information they had about this facility, it makes a perfect match with the number of objects listed on the code. And there was even subdivided as these objects were subdivided physically on the nuclear facility. And these objects were the centrifuges. More than 150 centrifuges were affected directly by the Stuxnet virus. And I want you to understand exactly how this virus affected these centrifuges. So, the virus was changing the parameters of the PLC to affect the spin velocity that happens inside the centrifuge to create uranium. In order to create this uranium, the velocity of the spin has to be very controlled and always has to be exact the same velocity the engineers wanted, okay? So if you reduce or augment this velocity, this spinning velocity, the outcome will never be uranium. So by doing this, they were stopping Iran to being able to produce nuclear weapons. The engineers were getting crazy because they couldn't know what was happening. The virus were also programmed to show in their screens that everything was going as expected. So they could see on their screen that the velocity was correct. Okay, so they could have no idea what was going on, why the uranium is not coming as they wanted. These variations on the velocity of the centrifuge spinning could cause terrible accidents. And this is why I describe this virus as totally revolutionary, because until this moment, every virus that was deployed successfully could cause damage, but this damage will stay on cyberspace. This was the first time that the virus had the potential of creating a massive explosion that could kill a lot of people. But beware, because this was clearly not their intention. They wanted to remain undetected, and this could be very difficult by blowing up an entire facility. That could have risen too many questions. These processes are very expensive, and on the other hand, engineers were getting murdered and getting fired because they weren't able to fix the problem. So it kind of was a matter of time before they ran out of people capable to attend this situation. Okay, so if maybe they had continued with a silent attack, at some point they could have achieved their goal, which was really to change their mind, the Iranian minds, about this whole thing, about the pursuit of a nuclear weapon production. And taking into account that the thoughts of the Iranians were around the idea that they were making something wrong and they weren't able to fix it, you can ask yourself, how long could this be unsustainable? How long will it take to them to decide that maybe it was better to stop all processes? So now that you understand what the virus was made for exactly, what was the purpose, I want you to take a moment to understand how it was meant to be spreaded. Okay? So at the beginning, this infection of millions of computers in the world wasn't planned at all. Okay? Apparently, and listening to the NSA agent confessions, we are driven to think that the Israeli government modified this code and deployed it without telling the USA. Okay? So, in the first place, the virus was meant to be spread in a very different way. Apparently it was requiring human assets, spies, that will infiltrate a couple of enterprises that were responsible for maintenance of some equipments in Natanz nuclear facility. So they were expecting to infect devices on these enterprises, and later, when the technicians went to the facility to make their maintenance, they will infect their computers by using flash drives or whatever. Okay? That was the initial plan. But the Israeli government didn't want to wait that long. Okay? Time was a crucial thing in this matter, so they wanted to spread the virus as fast as possible. So apparently, this government has changed this code and added these 0 days codes. And these 0 days codes, it was found out that they were created only to giving the capacity to this virus to spread without any action taken by the user. And this is very revolutionary, guys, because up to that date, every virus known needed the user to take an action in order to spread. So the user, the computer user, the system user, will need to download a file or open a website or plug in a infected USB flash drive on the device in order to get infected. But this virus didn't need any of these things. It will just spread. Okay? So they didn't fear too much about this because anyhow the computers that will be affected will be only the ones that they were targeting, right? But they draw too much attention. Okay, this attack was meant to be undetected, untraceable, and this attention, well, it just provoked them to be flashed out. Anyway, we are taking here the NSA agent confession as the real deal, right? But we can never know. So the consequences of this attack were not the expected, okay? Not only they were detected as responsible, even if it cannot be proved, right? But the nuclear program was only delayed by 1 year. After 1 year of delay, they will now know that they were being under a cyber attack and they will fix it. And how could they fix it? Well, Iran started in that moment and today could be one of the countries with a bigger or stronger cyber army at service. Iran couldn't respond with a military action, actually because these cyber attacks are not regulated by any international organization. In other words, they couldn't start a war based on what have just happened. Anyway, they have responded a couple of times with their own cyber attacks in the past years, targeting very important banks and oil enterprises in the United States of America. This attack changed the world. It has profoundly transformed warfare, and it has risen the interest of all nations to work in cybersecurity to fight cyber terrorism.